Okay, so for folks on the YouTube, today we're going to have a slight diversion from our typical structured approach. So today we're just gonna pick up questions which you can think of as at the JEE advanced level, and we'll try and solve 10 to 15 questions in the class. 10 to 15 questions in the class. Um, so and we will resume the regular relative motion and projectile motion step by step, question type by question type from next Monday onwards. Okay, so I'm going to jump into the live class and going to interact with the students there. Yes, Ruchika, please go ahead. Number 10. And Ruchika beta, I'm gonna go ahead and solve the question along with you, right? So that way, and you don't need to see what I'm doing. You can do it independently.
Sure, I'm getting A.
Sorry, getting A.
The answer I'm getting is tan alpha.
10 alpha. So let's just quickly understand.
Yes.
So this R, this can only move in the vertical direction up and down, and the wedge is accelerating. What does it say? The vertical acceleration of R is a1, and the horizontal acceleration of the wedge is a2. Let's say this way is a2. Doesn't really matter as far as the direction. And then the ratio given by a2. So let's first establish the relationship between their displacements. So if we were to move by a distance x, right? So if you were to move by a distance x, this is the new position of the wedge. Then the rod R will come down by this distance, right? So it will come down by this distance, and this distance is x, right? So if so let's say if we have this is the x, because once it moves, this point will be right below the rod, right? So point A will move to the right, and point B will come right below the rod R. So we just need to understand what is this distance AC. Given BC is x, then what is AC? Well, this angle is alpha. So AC would be x tan alpha. AC will be x tan alpha. Okay, so if you were to try and find the acceleration, A1 is nothing but d2x by dt2, and let's call this AC as y, and A2 is d2y by dt2. If you were to do that, we will see that A1 or A2 rather is A1. If I'm doing it right, let me know. But it looks to me that A2, right? The wedge acceleration is A2. So A2 is A1 tan alpha.
Sure, x is A2 and y is A1.
Y is A1. Okay. Y is A1. That's where I've goofed it up. You're absolutely right. A2 is this.
Sir, yes, is it A2 y by dt2?
Right. So in that case, we will have A1 by A2 as tan alpha. So A1 by A2 is tangent alpha. Let's move to the next one. Let's do question number 8. It's all about relative velocity, which is what we were discussing in the previous class. So this is a good question from that standpoint. Hi, Chavi. Beta, you are on mute in case you're trying to speak. Beta, we are doing question number 8. So let's do question number 8. It is to do with the relative motion, rather relative velocity. So please go ahead and attempt this question. So Ruchika, the Z is the vertical direction, beta?
Sir, is the answer D?
So let's just quickly see, beta. So what is the velocity that, so at any point, does it say it starts from rest? Observer AO at an accelerated trolley observes a projectile Q of mass 5 kg moving under uniform gravitational field of the Earth acting towards negative z-axis. So it doesn't really matter. So the velocity would be some initial velocity plus gt, right, towards the vertical direction. So in terms of the vector notation, we can write this as v is equals to minus v vector rather is minus u plus gt k cap. So this is the speed of the projectile Q as seen by the observer on the ground, Now let's look at the velocity of the observer O. The velocity of the observer will be something in the horizontal plane, right? So, or maybe we don't know, it doesn't say no that it's an accelerated trolley, okay, even though it hints, because the trolley is not going to be moving in the vertical direction, but it may be moving. So what do we know, right? So if the acceleration is acceleration of the trolley is ax I cap plus ay j cap plus az k cap, and if you were to write the velocity, let's say the initial velocity u is ux, okay, is ux I cap plus uy j cap plus uz k cap. Then the velocity of the observer at any point in time would be ux plus ax into t at time t I cap plus uy plus ayt j cap and uz plus azt k cap. As far as the relative velocity, so what will that be? That will be then this part, because of this part minus 50 t k cap, this is on account of this is the velocity of the projectile Q, or rather the momentum, right? And this one, if you divide it by 5, then 3t I cap minus rather plus 10 t square j cap. This is the velocity of the trolley, or velocity of the observer. I think that's what you are, that's how you're approaching it. So what you did is you said Okay, let me find the acceleration. Acceleration is dv0 by dt is equals to minus 3 plus minus 3 I cap plus 20t j cap.
So should it be 2t square j?
You are right. We have to divide it by 5. And by the way, so this is minus, so this is minus, not plus. This is minus 2t square. And Chavi, in case you're wondering why we are doing this, this is the momentum. So if you want to find the velocity of q with respect to the observer O, then that will be 3t I cap minus 2t square j cap minus 10t k cap. Take it up. And in fact, we'll talk about this approach that I've written down there. So Chavi, we are not able to hear you, beta. So you might be on mute.
So,
Yes, beta.
so what I was saying is I did not understand. So like you said, I did not understand the last part of what you did.
Okay, okay. So let me just first quickly write the expression for the acceleration. This will be minus 3 I cap minus 4t j cap. In other words, at t is equals to 2 seconds, this will become minus 3 I cap plus 8 j cap. Now, can you spot the error, Ruchika, in what I wrote here? Can you spot the error, beta? The error is I assumed that this is a constant acceleration. That's why I wrote it as ux plus axt, no? And it is very clear the acceleration of the trolley is not constant. It's a variable acceleration of the trolley, right?
Yes, sir.
In this case, we have to make assumption. We have to make assumption that the trolley is not having any acceleration or velocity component in the z direction. It's only moving in the horizontal plane. Then it's fairly simple and straightforward. So Chavi, what we have done is we've used the concept that v relative velocity of projectile q with respect to p is vq minus vo, right? Vq minus vo. The relative velocity of q with respect to the observer O is that, right? Momentum was given, so we divided that by mass to get the velocity vector. And once you had the velocity vector, we quickly said, okay, this minus 10t must belong to the projectile, and then the rest part must be the minus v observer. So v observer will be minus of that. That's why minus 3t I cap minus 2t square. Yes? But shall I explain it in a little bit more detail, or are we okay there?
Yes, so I did not understand the last part.
Achha, beta, last part you did not understand, no? Okay, so let's do it. So let's see if I can. Okay, so let's do it here. So what we are saying is that the momentum P, right, momentum P of the projectile Q with respect to the observer O is equals to 15t I cap, right? And what is momentum? mv. So mv and the relative velocity. And m is 5, and this is given to be 15t I cap minus 10t square j cap minus 50t k cap. Okay, so if you divide that by mass m, what do we get? Relative velocity of projectile q with respect to observer O then is 3t I cap minus 2t square j cap minus 10t K cap. Correct, Peter?
Yes, sir.
Okay. Now, what is V, Q, O? This is velocity of Q with respect to ground minus velocity of O, observer O, with respect to ground. Now, we know that the VO does not have, we will assume that VO does not have any component in the vertical direction. So, 10T K cap must belong to VQ. And VQ or Q is only moving, the particle is only moving in the vertical direction. That means this part is minus 10T K cap. And the remaining part must be minus V0. So this part, if I were to circle it here, this part must be minus V0. Yes, Peter? Is that clear?
Sir, but why did we make that assumption again?
Which assumption, Peter?
No, like why did we say that? Why did we just get the value that VQ has to be minus 10 TK cap?
Oh, okay. The mass, the projectile is moving. The projectile is moving in the vertical direction. It says it's moving under the uniform gravitational field of Earth towards the negative z-axis. That means that the acceleration is constant. First of all, its velocity is only in the z direction. So minus k, right? Minus k. Correct, Nobita?
Right. Yes, sir.
Yes. And the trolley, it says the trolley. By the word trolley, I'm assuming it's not moving along a mountain, right? Mountain range where it's going up and down, right? So I'm assuming it's moving in the horizontal plane.
Oh, okay, sir. Yes, I got it.
Yes?
Yes, sir.
Sir, even if the trolley was vertically accelerated, even then we could take out the force, which is equals to dp by dt, and then we can balance out the forces in the z direction. So we can apply
balance out the forces in the z direction. So let's say.
Sir, we can apply this pseudo force due to the acceleration of the trolley on the projectile plus the acceleration due to gravity.
So let's say the trolley is moving downwards, right? And it's accelerating downwards. So now it's not only moving in the x and y, but it's moving in the z as well. Yes, Vita?
Yes, sir.
Then how will we determine out of this minus 10k, minus 10t k cap, how much is because of VO and how much is the rest, right? We just.
Sir, we can find out the force by dp by dt. And sir, we know that force due to gravity will be mg, and the rest of the force will be due to the pseudo force of the trolley.
Okay, so let's.
In the k direction.
Sure. Let's actually investigate that, what you're saying. But what you're saying is this. Right? You're saying that this is moving, the force is mg, right? Gravitational force is mg, and which means the acceleration is g, right? Now, besides this, there is a pseudo force, right? Pseudo force, we don't know the direction of the acceleration of the trolley, but whatever the direction, there will be an opposite force. Let's say some randomly, so let's say it is in x, y, and z. Yes, Peter, what's the point again now? So what is the...
Sir, like in this case, we were given that a momentum to be 15 ti minus 10 t square minus 50 tk.
So what you're saying is, yeah, let me write it down. So net force is equals to...
So dp by dt. So sir, the forces in the x and y directions will be purely due to the pseudo force of the trolley that we can apply on the projectile, and the force in the z direction will be mg plus or minus the pseudo force of the trolley.
Sure, the component of the pseudo force in the... Yes. So, but
Yes.
So where are we headed with that? So I'm just trying to understand that.
So we know mg, so we can still take out the force due to the trolley in the vertical direction. And then we can divide it by mass to get the acceleration.
Okay, so let's keep going with this because it's important that we resolve it, right, Peter? So dp by dt, so you have this component, right? So you have 15 I cap minus 10 or 20 t j cap minus 50 k cap, right? This is the net force. Yes, Peter? Right?
Yes, sir. So,
This
so
is
here we can see that mg is the only force acting in the z direction since mg is equals to minus 50 newtons.
and why did you conclude that this is oh, so you are saying that the only thing that could explain it with respect to time is that because it's minus 10, so the trolley cannot be moving, um, so trolley cannot be playing any role there. So trolley cannot be moving in that direction, otherwise this will not be minus 50t, or the velocity cannot be minus 10t, right? Relative velocity.
Yes, sir.
Because 10t is purely on account of the gravitational acceleration. Hence, it proves the point that the trolley must be moving in the horizontal plane.
Yes, sir.
We didn't need to go, this is okay as well. So we all try and approach things from different angles. But good logic, Peter, good logic. So it has concluded, conclusively we can say the trolley is not moving in the vertical direction. Good logic. Okay. So Peter, you okay?
Yes, sir.
Okay. Beta, what we did is, so given the circumstance, I have changed what we were going to do today, right? We were planning to do some questions on relative motion, structured fashion, whatever we approach, the question type way. And we're just picking up these questions, which are JEE Advanced Practice questions, the one that I have sent you guys. So there are about 85 questions. So let's solve maybe 7 or 8 more questions. So we have less time. Let's see if we can pick up the pace. Let's do question number 11, please. So I'm going to go ahead and attempt it with you guys. Number 11. Okay. How are we doing? So let's quickly have a discussion here. Um, in the interest of time, so let's exchange notes. Ruchika, Chavi, how are you guys approaching it better? We will do this question type, Chavi, in detail, where if you are trying to find out the motion of the connected objects, and the first step that you can take is establish the geometric relationship between their coordinates. So here we're talking about A and B, and so we write down the relationship between the coordinates of A and B, right? Because the velocity of the A is along the minus y direction, the acceleration is also minus y, so it will keep moving along the y-axis. Yes, Peter? Yes, Peter? And we, even though it is not said, we are assuming that this is kind of a rod against the wall and the ground, so that B cannot move in the vertical direction. So B is going to slide along the x direction. In that case, x square plus y square is equals to L square. You differentiate it, you get 2x VB plus 2y VA equals to 0. So when x is equals to 3, y is equals to 4, then what is VB? We will get VB as plus, and VA is minus, because the way we have chosen our coordinates, we have to take VA as negative. So VB will be y by x VA. What is y by x? Y is 4, x is 3, and VA is 6, rather minus 6, but on this side it will be minus, there's a minus sign there, minus minus cancels out, so 3 into 6. So 8 meters per second. Now that we have that, so we're going to use this equation, so cancel out all the 2's here. So what do we get? VB square, that is 64, plus x, which is 3 into AB, plus VA square, which is 36, plus y, which is 4, and acceleration is minus 5, so minus 20, and this is equals to 0. Yes, Peter? I hope I have not left out anything in there. Differentiation wise, just check, Peter, if everything is okay there. Yes, looks like it. Looks like it. Anyway, so this is my.
Sure, it will come out to be.
Yes, Peter. So what is AB from this equation? This plus this is 100. So 100 minus 20 is.
So the answer will be minus 8.
Right. So minus 80 by 3. Answer is A. Okay, let's move on to the next question. Target is doing. Chavi beta, are we okay there? Chavi beta, is that
Yes, sir.
okay?
So I've done question like these before.
So you have done questions like these, no? Wonderful beta. Let's do number 12, please. Question number 12. I'll start solving it with you guys. So can I talk through the question? Shall I talk through the question or shall I wait? Let's do it together, just in the interest of time. I think you guys must be headed in the right direction. Chavi beta, would you like to guide me how to approach it? So I'm gonna set my clock. I'm gonna set my clock at the time when the ball one has descended by a distance d, and when its velocity is square root 2 gd. From there on, ball 1 and 2 both will fall with this for the same time duration, and one will cover a distance 4h minus d is equals to what should be d in terms of the balls hit the ground at the same time. Okay, good. So the time t is the same. Okay, so this is the distance. The u is square root of 2gd t plus half g t square. This is the equation for the ball 1. For the ball 2, the equation that I'll write is it is descended by height h, initial velocity is 0, plus half gt square. In other words, I'll replace half gt squared term with h. So if I do that, so what do we get? So in fact, let me just write, because we're trying to find d, so let me convert everything. So replace t entirely. So from this equation, t is square root 2h by g, square root 2h by g. And here this becomes then 3h minus d is equals to square root of 2gd into square root of 2h by g. So g cancels out, and what do we have there? So I'm going to write it down here. So 3h minus d is equals to 2 square root of hd, square root of hd. So let's go ahead and so we wanna find d. So for that, let's square the terms up. So what do we get? So we get 9h square plus d square minus 6hd is equals to 4hd. Okay, so the quadratic equation in d square that we have is d square minus 10hd plus 9h square is equals to 0. So let's quickly use our knowledge of quadratic equations to find the answer. So minus b plus minus square root of b square, so 100h square, minus 4ac, that is 36h square. 4ac divided by 2a divided by 2. So what do we have here? So we'll get h. What is this? This is 100 minus 36. Let's just make sure that there has been no silly error in the calculation there. So that should be, that'll be 63. Now something is not right here. What's not right here? Let's see. Let's quickly go back to our equations. So 4h minus d is equals to square root of 2gd. There is no problem there, times t plus half gt square, half gt square. For the second ball, the equation is h, it descends by height h, and that is simply equals to half gt square. So we have replaced that h in here. So that's one task we did, and then we also found out then we also established the expression for t, which is square root of 2h by g. That part also looks right. So what do we have here? So we have 4h minus d, and h, if I take it on the other side, it becomes 3h minus d. 3h minus d is square root of 2gd times time t. What is time t? Square root 2h by g. So that becomes 2 comes out. So if we keep it inside, it is 4 square root of 4hd. Doesn't look like there is any problem there. If there is no problem there, then do you guys have I overlooked something in the equations there? So this becomes 9h square plus d square minus 6hd is equals to 4hd. So then this d square minus 10hd plus 9h square is 0. So this is b square. B square is 100 square minus 4ac, 9436. Then the like there's a problem there. Now something is amiss. What is amiss? What is missing here? Are you guys following the logic?
Yes, sir.
Is that how you were approaching it as well, Chavi, Ruchika? Rest at a height 4h, long distance d. Ball is dropped from.
Sir, just from the options H is equals to D is the solution of the equation.
That is right. So how come?
Yeah, so I'm getting H is equal to D. Yes, yeah, same.
So how come? So where is my? So I'm doing something silly here. So what is that? So minus b, which is 10h, plus minus.
So, so Nietzsche, you've written D square minus.
And Ruchika is right. So if you put d equals to h there,
So you're getting it right. You're getting 100 h square minus 36 h square as 64 h square, and the root of 64 h square will be 8 h, and 10 h minus 8 h will be 2 h.
oh,
And
that's
so they're directly factorizable, right? You can just do D square.
I know you guys are pretty fancy there. Okay, good.
So you don't even need to use the quadratic formula. You can directly.
Yes, Peter. Whatever works should do. But overall, logic-wise, you guys are solid. Let's do a few more problems before
Yes, sir.
we run out of the time. Okay, let's do this number. Number 14. Let's see who does it first. So we're gonna race each other, okay? In the interest of time. This is theta, not q, by the way. So this part is 90 minus theta. This is given to be 1 second and 3 seconds. The maximum height of the projectile is what? What is the equation? Okay, so I'm gonna stay quiet. I'll let you guys work it out.
So 19.6.
19.6, okay.
So I'm getting 20 for some reason.
You're getting 20 something. So let's talk about the approach you guys are taking. Ruchika Beta, how are you approaching it?
No, I'm getting. Yes.
Seems I have lost.
Sir,
Yeah.
in the equation h is equals to u cos theta t minus half gt square, I first equated.
Yes, Beta, you.
Sir, first equation I got was by putting t is equals to 1, and the second equation I got was putting t is equals to 3. And then, sir, I equated both the equations. I found out u cos theta from there. And then, sir, using the third equation of motion, which is v square is equals to u square minus 2gh, we can find the h max.
Hmm. Okay. So h and u cos theta are two unknowns, no? And you said you put in t1 1 second.
Oh, okay. So I think I got what I'm.
Okay, Beta. So, Beta, how did you approach it? By the way, just a quick one, Ruchika. So, Beta, you had two unknowns. You cos theta as one unknown.
So same thing.
Go ahead, Beta.
Sir, I think you are receiving our voices a little late.
That's fine, Beta. Carry on. There must be some issue with the connection here. But go ahead. So you had this equation y is equals to u cos theta t minus half gt square. Okay, so what we're going to do is I'm going to stop the broadcast so that we can have more bandwidth for the live class. Give me a second, Beta. For the folks on YouTube,
Ruchika, did you use G as 10 or 9.8?
9.8.